As I said, we will focus on very basics, how to get familiarized with Flink, setting up a local environment for you to work, and get familiarized with Flink table APIs, which is suitable for SQL developers. We also will look at Flink SQLs and such. And after that, we will deploy the code we build onto AWS for a scalable and a robust environment. So why Apache Flink? Flink is designed for real-time processing, but as I said earlier, it's not just for real-time processing. You can also work on your file data or table data, which is like finite data. It's really fast and very efficient. Very efficient. It's highly scalable, fault tolerant, so you can really trust it with your critical data processing task. So we will cover bare minimum concepts. After that, we will deep dive into the hands-on part itself. The programming will be very limited, so we will try to make it easy to follow. And you can also do this without any Flink cluster or anything. You can do it on your local laptop, and then deploy the code onto AWS. We will take one step at a time. When you talk about Flink and Apache Spark streaming, we often think about a streaming job. You need to have streaming data source, and you need to have stream storage like Apache Kafka or Kinesis data stream. But that's not the case. Apache Flink can operate on batch data also, as in like file system or dataset from tables or RDBMS. That also works fine. So in this particular slide, I want to differentiate between a bounded data and unbounded data. So bounded data is always, there will be like a start and an end. So it's typically a data sitting in a table you can consider as a bounded data set. And whereas unbounded data set, there is a start but there is no end. It goes on to the future and it always continues. So the one of the main advantage of Apache Flink is Apache Flink comes with APIs which both support stream as well as unbounded as well as bounded stream without any differentiation. You basically write the code for a table that works perfectly fine for streaming as well. You don't need to code it differently for streaming jobs and non-streaming jobs. So let's look at how an Apache Flink application works and where it sits. Typically, the data from your applications, such as devices or logs or tables, it could be two form. One is stream, which is like a continuous form of data, and another one is like kind of static data, which is sitting on a table or a file system. So Flink can operate on both set of data at the same time. You could join, you could aggregate, you could filter, you could run any sort of transformation combining this data, and the end results of this transformation can be written into an application. That means like a downstream web application or mobile application can consume the data, or you can store this data into a database or another stream or even a file system. So with that, let's focus on setting up a local environment. It shouldn't take more than 15-20 minutes. You need to, so we are talking about only the bare minimum installation. Of course, you need to have an IDE, like which is a development environment. So my IDE of choice is PyCharm. You could do the same thing with uh, Visual Studio or some other IDE as well. And install Python 3, the latest version. After once you have installed Python, then we can do a package install of Apache Flink. So these are the bare minimum needed for setting up a local environment. We don't need to worry about a cluster or anything now. So here we are focusing on getting familiarized with Flink development using SQL and table APIs. Once the code is running and working fine, I will show how to deploy that onto AWS and make it like a scalable, robust job.